ของ DPCT นะครับที่จะพรีเซนต์เกี่ยวกับเรื่องโดยไฟฟ้าชีวมวลครับโดยเน้นเกี่ยวกับเรื่องของมะพร้าวนะครับและการใช้Giant King Gasในการเผานะครับขอเรียนเชิญทุกท่านเข้ามารับฟังและรับชมพรีเซนเตชันนะครับแล้วหลังจากพรีเซนเตชันเราก็จะมีเกี่ยวกับมินิค็อกเทลนะครับเกี่ยวกับของมะพร้าวนะครับน้ำมะพร้าวผลิตภัณฑ์จากมะพร้าวนะครับขอเชิญเลยครับ
I'll start with grass. Okay, so initially we planned to call this event Grass and Cocktail, but we believe that we will have some trouble with the local authorities, so we decided to name it only Coconut Cocktail. But I will start to talk about grass. And by grass, I mean energy crop in the what I will call the king grass family. King grass, okay, can be called with very different name. It's a type of grass that we found in most parts of the world, from north to south, and mostly inside the tropical belt, like in Thailand, in Indonesia, in Brazil, in Honduras, in West Africa. This grass, you might know it like Napier grass, for example. This is maybe the name you're familiar with, but it can be called also Giant King grass. It can be called switchgrass or maiden grass. Maiden grass, that's a nice name. So what is the difference between these different type of grass? The main difference is the yield. And by yield, I'm talking about biomass production per hectare. And why is it a very important factor? Because it will be the data that will enable you to calculate what is the surface you need to grow this biomass to produce a certain power generation. So you can see that from the reed canary grass to the giant king grass, the yield can be multiplied by 20. So I have put here on this table the number of hectares of a species that you need for a 30 megawatt electrical power plant. Why 30 megawatt electrical? Because this is a size where DP Cleantech is very familiar with, and I've calculated according to the calorific value of the fuel to the yield per hectare how many hectares you need for such power generation. What is very interesting about this energy crop, this grass, in fact, is to be able to have what I will call a co-located model, a plant that is located with a plantation. Because as you know biomass, the problem in biomass is biomass. And it's very difficult sometimes on some fuel to be able to completely mitigate the risk of fuel supply. When you have a co-located plant, you're going to be able to solve most of the supply risk. Okay, you will have control of the cost of fuel because you're growing it. You will have availability. You can even have what I will call just-in-time harvesting. So it's a very lean word, but you can create your harvesting plan according to your power generation. Today I'm burning these hectares, tomorrow it's going to be this part of the plantation. And of course, it reduces considerably the local transportation cost. It's a break. So transportation cost, why? Because if you look at what is your cost of biomass, you'll find out that in some places 30% of your fuel supply come from the transportation cost. So having your plant co-located with your plantation enable you, in fact, to reduce this cost and therefore to have a more profitable project, or to be able to have a better purchase agreement because you are able to provide a lower electricity price. But most of the people I met are like, okay, I have these 2,000 hectares and how I'm going to harvest it. And I have an example of harvesting in South America. This is from a Honduras project. This machine, in fact, is able to harvest about 1 hectare per hour. So if you look at the consumption, basically of a 25 ton per hour with 100 ton of yield, you'll be able to with 1 hour to be able to harvest fuel for 4 hours operation. And this fuel is directly shredded and then go to the truck and then go to the plant and it's fed inside the boiler. low-dose energy crop is what I will qualify as good fuel. Good fuel what? Because in fact, if you look deep in the chemical composition, it is very, very similar as straw. And straw technology has been, you know, the bread and butter of DP Cleantech. It's something that we are very familiar with. We've done about 40 power plants running on straw, and therefore we are very confident and very comfortable with those energy crop because it is close to straw. This is an example of our typical technology, okay, our straw fire technology that use for people that are already familiar with DP Cleantech. I'm sure you feel comfortable looking at such drawing. You will have our traditional vibrating rate, which is our main combustion system, which has the advantage to be very flexible and to be able also to handle fuel with low ash fusion temperature. You can have for feeding, as you've seen on the harvesting, some shredding grass coming to the plant. So here you have a feeding system that can handle shredding fuel. But we can also have something that can handle fuel by bale. An example you have here, which is Finsvaket in Denmark. So there is, for DP Cleantech, a lot of different solutions from straw that can apply to those energy crop. I've put also example of fuel consumption. I mean, DP Cleantech is well known for having the highest efficiency, highest power efficiency here in the biomass world, with power plants that are around 30% and above in electrical efficiency. Which means that, for example, for a 30 megawatt electrical, you'll need about 27 tons per hour of fuel to do 30 megawatt. Now, let's talk about coconut. And I think that Narissa and Aminta are going to serve coconut, and you will have some coconut in hand very soon. If you know coconut, you know that there is a lot of waste from the coconut industry. Okay, you have the fiber, you have the shell, you have the frond, as you can see it, that's from the leaves that you can find on the road. The branches, and where the coconut is on. And all those wastes are, in fact, right now lying around in countries like Thailand. If you go to Samui, for example, everybody knows Koh Samui, the island. Samui in Thai means coconut, and there's a lot of coconut in Samui. We have in DP Cleantech a reputation to be kind of hands-on, and you can see this is me just in front of a landfill, where in fact coconut industry are just disposing the coconut. No, this is just landfill. If you look at coconut shell, can Narissa bring me a coconut shell, please? Not this one. Yeah, so this is a coconut husk. I think you can get some drink over there. What do you think is going to be the main problem, okay, in power generation from this coconut husk? Do you have any idea? Sir? What could be the problem with this fuel?
Well, moisture.
Yes, moisture, exactly. This is a waste that is very, very fresh, about 65 to 70% when it starts. So it's a very, very high moisture content fuel. What else? Sir? The size, yes. The physical properties. It is, even if it's something that is seen inside, it's something that is cumbersome. And the last one? What? Corrosion. Sir? Corrosion, yes. People that know a little bit about the chemical property of the coconut will know that coconut has a high chlorine content and a low sulfur content, which means that it is a fuel that will have a tendency to be corrosive. So the challenge is what we say, the moisture content, the fuel preparation, but it is linked in fact to physical properties, and the corrosion. As you know, at DP Cleantech we take new fuel very seriously. Okay, we have hand-on experience on about 50 to 60 different types of fuel. And it's very important when we have new opportunities to work on a new fuel to really go deep into the detail about the property of this fuel. And this is why we do very deep fuel assessment to compare to what we know, what we have done before. So we analyze moisture content, we analyze corrosion potential, we analyze drying behavior, falling, ash melting, and then we compare what we have to exactly this new fuel. I've done here the same with coconut. So this is a map of fuel that is used by DP Cleantech today. And some people are already familiar with this map. I really like to show it. But basically, here you have this axis where the corrosion potential, here is the highest corrosion, here is the lowest corrosion. Wood, which is in blue, is what you know, what everybody is doing. It's a very easy fuel, very low corrosion potential. Straw or heather and bark are in the middle and have a high corrosive potential. And you can say that some straw are going in very, very high. Here it's the rice straw. Okay, people are starting to talk about rice straw too, but why is it difficult? It's difficult because it also has high corrosion potential. And you can say that coconut, so here you have the stem, here you have the husk and shell, and coconut corrosion propensity is very close to the one as straw, which means that the mitigation that we had to put in place for straw firing has to be used also for coconut, because if you put this coconut husk and shell inside a typical power station, it's not going to work. You're going to have superheater blowing 6 months later. So it's very important to have the right material, the right sizing, and the right, I would say, technology or IP patent as DP Cleantech has for such fuel. If you look at falling, which is basically how the ash will form around the surface of the boiler, the falling propensity of the coconut, in fact, is quite all right. You are in the wood section, okay? So you should not expect with coconut waste to have any major falling. However, when you link it to the ash fusion temperature, then it starts to be a bit tricky, because you can see, and again, we see how the wood are easy fuel to burn because they have a very high ash fusion temperature. Coconut is very low. It is at the level of what we know all as being a very difficult fuel, the EFB. What does that mean, this ash fusion temperature? It means that we have to be in the design very, very careful about at what point inside the boiler, inside the furnace, you are reaching this temperature. If you are in the furnace, normally we are far above. We are 1200, so we are in gasify, so everything's all right.
Well, the main economic and political factors are really that there's a big need for power production in the Asia-Pacific region. The governments are developing their regulation set. There are guaranteed feed-in tariffs which are necessary to get financing for projects, and there's grid connection possibilities that are being developed.
I think this is determined by also the industry where one developer likes to start. For example, mining. Mining currently is relying on a lot of power generation from heavy fuel oil, which used fuel as a heavy fuel oil. This is very expensive and only goes up in price. So when the mining corporation in Southeast Asia is able to use the local resources, it can definitely reduce its cost and still generate the same amount of electricity. So this is something where it definitely benefits the part. I think the physical part you said, right? I think physically our power plants are built to operate for well, maintain once or twice a year for a brief amount of time. Within 4 years we normally do a large overhaul, and it's been proven that this is it can be done with actually our plants can run with a minimal amount of maintenance. So of course we have quite a few staff in Asia that can maintain these plants compared to Europe, but it has another benefit in the sense of creating an employment for the people, for the villages and plantations around it. So there will be a lot of benefits from it. Of course, eventually the emission standards, we have a carbon neutral cycle where we make sure that whatever is burned is absorbed back again into the crop, and this circle goes around. So this is something I think that's definitely a benefit of DP Cleantech.
A lot of people are asking what enables biomass to power to spread and develop in a particular country. It is very important to understand that it is, and it starts with one very important first step: government incentive. It needs to be pushed by the government to, in fact,
motivate project developer to start to investigate biomass. It is government incentive, legal framework, feed-in tariff, all those legal items that will push this industry. Of course, it is important that there's fuel, but when we look at Asia Pacific region today, it is more than 30% of the global biomass supply in the world.
Best locations are really in Thailand and Philippines, because they have all the framework conditions in place with the feed-in tariffs, political support, grid connection. The next markets that are developing these conditions very fast are in Vietnam, Indonesia and Malaysia, where we expect a huge potential in the very near future.
All right, I think the best locations in Asia Pacific are actually Thailand and Philippines. They have been basically promoting their biomass production and biomass power generation for about many years, whereas Malaysia and Indonesia do have the biomass available, but the government incentives are not in place yet. So it's just a matter of time, I believe. It would be another perhaps two to 3 years when they are going ahead, and yeah, then we'll see how that picks up. But I think Thailand and Philippines are definitely ahead of the game.
Today, the best countries to build biomass power plant are Thailand and Philippines. And why? And we come back to the point number one, which is about the legal framework, is that Thailand have developed since I think about 10 years now a very specific program called the VSPP program that enable project developer to have easy access to license for 10 megawatt electrical plants. Philippines on the other side just released their new feed-in tariff, which is very high in fact for the region, more than 16 US cents per kilowatt hour, which will enable biomass to be massively developed in the Philippines. Philippines being an island country, it's also very important for them to have a local power, and local power in all of their island.
I think Southeast Asia is the best location because there are plenty of fuel in this area. And I think it's also easy for us to understand the culture around here. So I think it's yeah, Southeast Asia is the best location, as my opinion.
Our challenges for the project developers are usually to secure the fuel supply. In the Asia Pacific region, the waste from biomass is mostly owned by very small organizations and farmers. So our clients have to secure the fuel supply from cooperatives, for example. And then, of course, the political framework, the feed-in tariff needs to be defined. This is a challenge when it is not.
Okay, I think it could be two categories. First one is logistics. Our plant sizes are between 10 and 40 megawatts, and you can imagine that with 40 megawatts you need a tremendous amount of fuel. So getting all the logistics in place to make sure the fuel arrives at the plant on time, as scheduled, in the right quality, that is something that is challenging for customers. So you see a lot of plantations starting to be around the plant. That's one of the solutions. Number two is the challenges is actually the incentives that the government has not really recognized yet. I think especially Malaysia, Indonesia, and some other countries in Southeast Asia, they're starting with it, but it still takes some time to get these incentives in place to really recognize the benefits of biomass.
And the main challenge to do biomass is of course the fuel, because the problem in biomass is biomass. And you can say the very big difference between Europe, for example, and countries in Southeast Asia is that the agriculture is fragmented. I mean, a lot of farmers have a small portion of ground and they are cultivated on it. And therefore, it's very hard to have a full contract of fuel supply, which means that the risk of fuel availability, of fuel price is very high.
I think the main challenge is about how we can communicate and introduce our technology and our reference, our reputation to the people around here or to the owner, because they are quite because it's a new technology and the investment is quite high also. So they need someone to work as a consultant or their partner to explain them, to introduce the technology and to support them, to do some feasibility study, to let them know more about the technology, and then they feel safe, and trust in our technology. So we have to work like a partner and friend, not only like a supplier and owner.
We support our clients in supplying plants which are multi-fuel capable, so they are not depending on only one kind of fuel. They can use different fuel supply sources. That is the main technical reason for the clients to use our plants. We help in the early political framework preparation process and presenting the technical performance to governments and the low emissions, also to convince the local governors.
Okay, I think I kind of mentioned that already. How can we get around these challenges? It's basically bringing the fuel to the plant, bringing the plantations nearer to the plant, getting it properly, getting proper energy crops, like for example giant king grass, getting it growing nearby, high yield. Every 4 months we can do another harvest. That is something, and especially Southeast Asia, the weather is perfect to have these kind of high energy crops, and that's one of the challenges. The other thing is DP Cleantech is working on their awareness to show their technology. It's still a lot of companies have medium temperature, medium pressure, and are not aware of the next generation boiler efficiency. So they haven't seen that yet. So we're kind of working on this. So within the next probably 3 to 5 years, this will start to pick up, and yeah, we will definitely see an explosion of high energy, high pressure, high temperature plants.
So obviously in a country like Thailand, biomass has spread, which means that we found mitigation against this problem. And you can say that organizing the rural life is very important, working with collaborative, creating a sustainable farming program, dealing with energy crop, for example, or interesting the local community in the profit of the power plant. All are mitigation that has been put in place by the project developer in Thailand, and I think this is the way to go.
I think yes, we should work like a answer before. We should work as like a partner and friend, and we should understand what is their needs. Every country they have their culture, and the way to start the project is different. If you work with the government, their knowledge is not enough. You have to work as a friend and introduce and support them in every issue that they want you to support. But for the owner or some company that they have some technical guy, so you will work like a consultant at first, not like a friend, or to give information more detail like a governor, something like that. So we have to choose the target and different approach.
The landscape is very wide. We have a huge market in Asia Pacific. Everywhere is a need for energy, huge supply of fuel, waste fuels in all the Asia Pacific region, which is untapped for some kinds of fuel. So we are looking at a very bright development here in many markets.
I truly believe that this will grow in the next few years. We're on the brink of getting very large power plants, just basically on biomass. So it's just this little step that needs to be done before it's going to go into an exponential growth. So I think the possibilities are endless, especially in Thailand, in Philippines, where the incentives are already in place. Malaysia is upcoming. Indonesia is a huge country, many islands who need some local power, which is all very dirty coal-fired plants at the moment. They can see a perfect alternative into biomass, and it's just something DPC can easily provide. Yeah. I think number one is awareness. You see in Southeast Asia, you see a lot of small-scale power plants based on low-end technology. I would say medium temperature, medium pressure. DP Cleantech brings something else to the market, a level further, the next generation. High efficiency, high pressure, high temperature. It's something that can put your boiler up to 91% of efficiency, and that is miles ahead of the current existing technology. So as we're speaking, we know all about that, but it's not aware in Malaysia and Indonesia. It's not recognized yet. It takes some time. I do believe people see the benefits of it. DP Cleantech can actually provide the solution at a good price with manufacturing facilities in Asia already, but still using the engineering technology from Europe. So we hope we can enter this market very soon, and actually we believe in this as well.
Asia Pacific in biomass is the future, and I'm going to tell you why. Because, as mentioned, you have most of the biomass in the world are located around this area. Massive amount of resources are available, from the forestry, the sugar industry, the rice industry. But when you look at the gigawatts that are produced every year, or the country that are exactly using biomass, is in fact very limited. Only Thailand have 10 years history in using biomass. Philippines is just jumping in. But when Malaysia, Indonesia, Vietnam, Cambodia, Myanmar are going to jump into Southeast Asia, it is going to be massive. The whole industry is going to be dragged into Southeast Asia in building biomass power plant. And I have talked about Southeast Asia, but we should talk also about Pacific. Australia just released a new policy, and you can say that the crop industry, corn, wheat in Australia is very big. They have also a lot of potential. All those Pacific islands will need power, and biomass is the best power for that, because it's local and it's base load and it's renewable. And one day, maybe not today, because of course you need time to put this policy framework in place, but one day those islands will also develop into biomass. And this is why Asia Pacific is the key for the biomass industry today. Feed-in tariff, it's all started with feed-in tariff. Feed-in tariff is important because it helps you to make your project the most profitable possible. It attracts investors, it attracts project developers.